In this section, we're going to be finding some absolute extrema. So we want to find the absolute highest and absolute lowest points on the graph. This is called optimization when you do it in real life problems. There are careers in optimization where people try to optimize something, find the most optimal amount of something, which is finding absolute high or absolute low. The definition of an absolute max is whatever x value gives you the highest y value. It's bigger than or equal to all other y values. For instance, your highest point could be at 7, the y value 7, but you might have 1 going to 7 and -1 going to 7. So it could have two x values going to the highest y value. Absolute min is going to be wherever an x value gives you the lowest point on the graph, where it's lower or equal to the other lowest point if there are multiple for all x. So we're looking for the absolute highest and absolute lowest points. We've done relative extrema before. We're going to start off with finding absolute extrema the same way. We're going to find critical numbers, which means we're going to set the first derivative equal to 0 and solve. That will give us our critical numbers. It'll give us the soft peaks on the graph. And what is a relative max could also be an absolute max. Same thing, what's a relative min could also be an absolute min. So, for example, if the shape of the graph is just a regular old parabola, well, the critical number would be right here, that soft peak, and it's going to have the sign change negative to positive. So it's going to be a relative min. But also, comparing it to the end behavior, that relative minimum is also an absolute min. So you may find that a relative max or min is also the absolute max or min. The second step is to find the y values at the critical numbers and compare those to the y values at the end behavior of the function. So we do not have to make a sign chart unless we're missing one of our endpoints. We need to figure out what the end behavior is. So either we're on an interval and we just compare y values of the critical numbers to the y values of the endpoints of the interval, or if we're missing a bound on our interval, that would be the only time we would have to make a sign chart to figure out, is this going to be an absolute min as well as a relative min or something like that. Again, we're going to call the highest y value, we're going to say that occurs at the absolute maximum. And the lowest y value is going to be at the absolute minimum. We're going to look back at some previous pages and see if we can find absolute versus relative extrema. So absolute means compare end points / behavior, versus relative extrema is just critical numbers with a sign change. Changes from decreasing to increasing at the critical number, you'd call it a relative min. Changes from increasing to decreasing, you call it a relative max. So if we look back at our previous pages, we're going to flip back in the notes packet to graphs we've looked at before. So here we have a graph where we found concavity before, and now we're going to see if we can find extrema. So we can start with what's more familiar, a relative max and relative min, which is just going to look at critical numbers. We're looking for critical numbers that have the right sign change, something familiar. So I'm going to label this graph according to the first derivative. So I'm just going to figure out, am I rising or falling left to right? At first, if I'm tracing this, I'm rising, so I'm going to label this as a positive first derivative. Then any soft peak is going to have a derivative of 0. There's one of my critical numbers. Next part of the graph is falling left to right, so I'm going to label it as a negative first derivative. And then we have another soft peak, that's where the derivative is 0. And then we have a positive first derivative to end it. It's rising left to right. So these relative max and min, we're just going to look at the critical numbers. If you want to, you can make a sign chart out of them. We have a critical number at -1 and 1. So if making a sign chart helps you, you can do that. You might already be able to tell just by the graph which one's a max and which one's a min. If you can, I wouldn't spend time on a sign chart, but if you are not sure or just want a way of checking it, make it into a sign chart. You're going increasing to decreasing at -1, so rising to falling. So that one's going to be a relative max, is at -1. And then we would look at the graph to see the y value of the point. It's not quite up to 1, it's somewhere between 0 and 1. We could maybe say 0.7. And then after 1 on our sign chart, we'd put increasing. So there we switch from decreasing to increasing. So we have a relative min at the 0.1 comma. We're going to look at the graph to see the y value. It looks like 1 comma, maybe -0.7. So all you're looking for is sign change at a critical number, and that gives you relative extrema. Absolute extrema, absolute max, and absolute min, you compare critical numbers to end behavior. We're going to look at those critical numbers, those relative max and min, and compare it to the end behavior and see if those those relative max and min are also absolute max and min. So looking at my relative max that we have here, is that relative max point also the absolute max? Well, I'm going to compare it to the end behavior to the left. Yes, it's higher than the end behavior to the left, so maybe that relative max could be an absolute max, but I also need to compare it to the end behavior to the right. And to the right, it's going up to infinity without bound. It looks like it keeps going up. So is that relative max also the absolute highest point on the graph? No. That end behavior to the right proves that it's going to get higher than that relative max. It's higher than what's around it. It's a local or relative max, but it's not an absolute max. There is none. It's going up without bound to the right, so we would say there's no absolute max. To find absolute min, we're going to compare our critical number where we had our relative min to the end behavior. Is it lower than all the points to be an absolute min? No, because to the left, it goes down without bound, so already we can spot several points that are lower than our absolute min, or relative min, making it not an absolute min. So there are none. We're going to do that same thing on the next page. We're going to find any critical numbers and base whether it's a relative max or min off the sign change, and then we're going to compare it to the end behavior to see if we have any absolute max and min. So looking at our next page, I'm going to start just by finding these critical numbers. So critical number would be here. It's a part of the graph where it looks like the slope is 0. Same thing, critical number here. It's a part of the graph that looks like where the slope is 0. A soft peak or constant part has a derivative of 0. And then labeling the graph before our critical number, it is falling. And then between our two critical numbers, it's also falling. So another negative first derivative. And then after our critical number, it's rising again. So we have falling, falling, and then finally rising. So again, if it helps you to make a sign chart, you can make a sign chart out of this. My critical numbers are 0 and 3. This is my sign chart for f prime. They both have a derivative of 0 there. They're our critical numbers. This is where relative max and min could occur, and it could also be absolute max and min if we compare it to the end behavior and it's the absolute highest or lowest point. So before 0, we are decreasing. After 0, we're also decreasing. So do we have a relative max, min, or neither? That one's going to be neither. It doesn't have any sign change. Next one is decreasing to increasing. So we do have a sign change because it's increasing after that critical number. And we want to remember decreasing to increasing, that gives us a relative min. So as far as relative extrema go, for relative max, we have none. Relative extrema are just sign change at a critical number. We don't have one that goes increasing to decreasing, like what we would need for relative max. For relative min, I would say this point here we have decreasing to increasing is relative min. So we need to find the y value of the point. So the point is at 3, comma, maybe negative 3.3. Hard to tell because it's a decimal. Now, if we try to find absolute max and min, all we're doing is comparing our critical numbers to our end behavior. So looking at our critical numbers and comparing it to the end behavior. So for absolute max, well, there wasn't a relative max. So both of these critical numbers are not even a relative max. So I wouldn't consider them to be an absolute max. I would just look at the end behavior and see if there's a spot where it seems to stop at the end. And on both sides, it looks like it's going up without bound. So I would say there is no absolute max. It looks like it's going to infinity on both sides. So there's none. There's not a certain point where it stops. We're at like 5, 100, and we know that's the highest point. For absolute min, comparing my critical numbers to my end behavior, well, this critical number at 3 was a relative min. So I want to take that critical number and compare it to the end behavior. Is it lower than both ends? Well, it's lower than the left side, and it's lower than the right side. So it is lower than both of my end behaviors. So I can call that relative min is also an absolute min on the graph. It is the absolute lowest point. So again, relative extrema, you're just looking for sign change on your sign chart, just like we've done before. Absolute extrema, you're comparing those critical numbers to the end behavior, seeing if a relative max is also the absolute max. In this case, our relative min is also the absolute min on the graph. There's no lower point you could find.